Hello again. This is the second part of the previous presentation, which title is Windows Mobile 6.5, what is new in Windows Mobile 6.5 kernel. And these two presentations are actually different in a way, but they come together. First one talk about the changes, and the second one talk about how to take advantage of these changes to to gain better performance. The So that's the actually combined agenda for part 1 and part 2. Part 1 talk about the introduction of slot 60 or 61 for DLLs which are loaded either module or file section, as well as it's also talk about the use of slot 59 for the device.exe thread stack using the virtual memory from slot 59. And if you really need to know more about it, please go through with the previous presentation, and you will learn about it. The second part 2, which is this you are really going through, it talks about the taking advantage of the changes made in this Windows Mobile 6.1 plus, or up to I would say the 6.5 is the latest, so up to 6.5 C kernel. And the topics includes the efficient use of virtual memory, and it also tells you that how you can take the advantage of the new changes to gain the best results. There are a few slides which are the review related with the previous presentation. So here is we have that in Windows Mobile 6.1 we added two new memory slot 16 and slot 61 to handle only DLLs which belong to file section. We also added slot 59 for device.exe threads virtual memory, so all the threads in device.exe can use the slot 59 virtual memory, so that we can gain about 8 megabyte of virtual space in device.exe, so we can add more DLL, or we can load more DLL in device.exe, or in other words, we can load more drivers in the Windows mobile devices. And so that was the change we added in 6.1. Then we made some changes in that design in 6.1, which is 6.5 now. And the first change that still we are using slot 60 and slot 61, however we made it available for module section DLL. So all the module section DLLs can be loaded in slot 60 and slot 61. However, the slot 60 and slot 61 can accept the read-only part of the DLL. However, the read and write section of the DLLs are still allocated only in slot 0. So that's the changes we add top of Windows Mobile 6.1 as names Windows Mobile 6.5. Okay, here is the cumulative details came with 6.1, 6.5, or you can say, and what is in 6.5. So we have slot 59 for device.exe, slot 60 and slot 61 for your module and file section DLL, and then module section DLLs, they can be loaded into slot 0, 1, 60 and 61. That helps us to improve the DLL load speed, and if OEM will place every DLL in module section, it also simplifies the platform build process. And because the module section DLLs are 4 KB aligned versus file section DLL which are 64 KB aligned, it provides a more granular memory management that reduces the waste of virtual memory due to the size of these DLLs. Another slot summary, that in Windows Mobile 6.5, I would be just talking about only the last one, Windows Mobile 6.5, that all the files, all the DLLs from either a file or module or file and module sections can be placed in slot 60, 61, 0 and 1. And if you look for fill order, the file section DLL they take from 60, 61 to 0. However, the module section DLL they go from first then 61st, then 60th, and then 0. Okay, so best practices to use virtual memory, and that's you can really, I provided a little information about it in previous slide, but here it's in detail. Same information is in detail. So how to take advantage of virtual memory? Use module DLL instead of file DLL because they are efficient, because they use a smaller 4K alignment, boundary alignment, and they load faster because there is no fix-up needed for those DLLs. DLLs which are in slot 0 reduce the code size for the DLL, and the the data size you also need to reduce for all, because all the data is slot 0. So as you know that the DLLs which are in slot 0, they have their code and data size together. That's why if you are placing a DLL in slot 0, you need to reduce the code and data size for the DLL as much as you can if you are going to place in slot 0. And I have also talked in my previous presentation how you can force a DLL to be placed in slot 0 with its code and data section as well. And another idea that consolidate multiple DLLs into one. So if you are trying to have a DLL which is in slot 0, then it is really very important for you to have a DLL aligned properly, and then if you have multiple DLLs, they'll try to merge them together to make one single DLL to reduce the waste of virtual memory. And as you know that the file section DLLs are 64K line, however the module section DLLs are 4K line with some restriction. If the DLL is moved from slot 0 to slot 61, then what you will need to do, you need to enlarge the paging pool. Reason, because just to avoid the performance hit, you are going to experience using the when the module is really going to paged out and paged in. So that's why you really need to have the paging pool bigger, then DLL won't be paged out frequently. And here is another way, that if you think about, you have multiple DLLs, they are loaded in a 64K aligned DLL, 64K aligned DLL space, and in process. So there is a process A, there are DLL 1, 2, 3 loaded, and then there is some empty space, and there is a DLL X, and then there is process B, there are DLL 1, 2 loaded, and then DLL 3. In place of DLL 3 there is empty space, and there is DLL 4, and then DLL X that is in process B. So that's an example that you have. In the next slides, what we are really going to talk about. We are taking the information from here, and then we will try to provide a few scenario to understand this behavior. So let's take an example that SQL mobile module load primarily in file6.exe. Therefore, the space that is reserved for this SQL server module in other process besides file6.exe is empty, because it's really not really going to be used. So that's, there will always be a hole for every other process comparative to file6.exe. The allocated mobile SQL module virtual memory space in the process is actually considered a waste. So this example is explaining to you that if there is a DLL which is called by one single application, is really useful for that. So the memory, virtual memory, which is used by the DLL is useful for that single process. However, the other process, that virtual memory hole, is really a waste of virtual memory for other process besides the process which is using that DLL. So once we have understood this example, let's go to next slides. So in the previous image, the empty space in process A and the empty space in process B can be reallocated. So let's go back. What I was talking about here, that once you have these gaps here, and these gaps are really showing that this is the hole, because in the same area a process X or is we can think about in these two processes that this, because the DLL4 is exclusively loaded for process B, that's why the space in DLL in process A will be waste space. However, DLL3 is exclusively loaded in process A, that's why the empty space in process B is just waste of memory. So this space which we have here can actually be reallocated, so it's not waste. There is a very smart way to create your image, or you place your modules in you will define in the registry so that kernel can take advantage of that. So the DLL space that is reserved for modules that load exclusively in one process can now be reallocated to the other process. So the point here that if you have a DLL which is loaded exclusively in one process, then the hole which is created by that DLL in every other process can be reallocated when it's needed. So what actually happens that when a virtual alloc call is made in a process which search, okay, if there is a range of virtual memory available for this process, and if the module which is exclusively loaded to a different process, but it creates a hole in the process where the virtual memory alloc call is made, then the kernel will allow that virtual alloc call to be to take the advantage of that hole or the block which is available because of DLL exclusively load in a different process. If there is no gaps available, then the normal virtual memory algorithm can be used. Or if there is no gaps in that process, means everything is pretty much as normal. Okay, so how to get more virtual memory? Okay, so the trick here that actually operating system maintains a list of possible virtual memory gap in each process. So how it happens, you have lots of DLL, and then all these DLLs are actually loaded by this process. And if we know that this particular DLL is actually exclusive DLL, you just need to tell to the system that hey, this is the DLL is the exclusive. Then whoever loads that DLL, kernel will know that that DLL is actually exclusive for that process. That's the way you are telling to the system. And because of that DLL which is loaded in certain process, the DLL hole or DLL gap is created for the DLL in other processes. Then kernel really track those holes, and so that it can really reuse them. So these gaps are the virtual memory ranges in which a DLL is loaded exclusively in a different process in that address range. So I just explained it. And the third point, because that DLL is not going to be loaded in the current process, kernel will allow the application who is making call to reuse that virtual memory. Here is the list like a kernel really maintain, that is a process 1, process 2, process 3, or actually it should be TLL, and sorry, it's still a process, but it's depend on TLL. So these are the gaps is really maintained as properly. I think the next slide talk about how that really kernel really maintains. This is just a visual representation to create an image in your mind what is really happening. So what kernel does? So the list of gap consists of a byte array per process with 64 byte. The array is owned and maintained by kernel. Each bit in this array represents a 64 KB block, so 64 multiplied by 64. This is a 64 byte array. Perfect. And if the bit is set to 0, it means that block is not available, and if the bit is set to 1, that block is available for. So that's the way for every process. So we know that we have 32 process, and then there will be 32 byte array, and then each byte array will have 64 bytes to represent a 64 KB each byte. So and you can understand the math here. And because we are talking about 64K alignment here, then you might think, oh, what is really going on further? And in next couple of slides we'll really talk about this thing in detail. So when a new process So how, okay, so this slide talk about how we really maintained it. So we have a process called init vmmap.exe, and what you can do when you load a Windows mobile device connected with platform builder, you can really see at certain time that init vmmap.exe is really started, and that application is really maintain this thing for in the device for you or for OEM who really want this thing, this efficient virtual memory management is happening in their device. Or if you have already running Windows Mobile 6.5 device, then you can really look into the process explorer, and then you will see that init vmmap application is running there. This application is start. This application read the registry to look for every DLL which says that, oh, this DLL is actually exclusively going to load in process whatever whoever will load it. So if there is a DLL related registry available, then this init vmmap application will look and will understand that, oh, if that DLL with any module in any process wherever this DLL space is available, that can be overwritten by the same in the process anybody who wants to use that virtual memory. And if somebody really want to change the DLL settings in this registry, then they need to really change the registry, then they need to restart the device, so that init vmmap application can again maintain the list. So you can't really do in fly this thing, you have to reset the device after making changes. So what OEM can do, if OEM know that their DLL XYZ is actually loaded only in process A, then they can place this DLL name here. Okay, so and then once that DLL name is there, the init vmmap during device boot up time will understand about that DLL, and whichever process will load that DLL, that area, that virtual memory used by that DLL will be only exclusive to that process, and the gap created by that DLL in other process can be reused by other DLLs in that process when there is a need for that virtual memory. So this is something I would explain. I would put in terms that is very efficient use of virtual memory. If OEM know or developer know, they can really take the advantage of this change, and that will really help them to efficient use virtual memory, because these are really small devices. They really don't have large resources of virtual memory as we see in C6 for user mode kernel mode separation. So we have to really look for the changes what Windows mobile kernel developer they really designed these changes to help ISV, OEM, driver developer to take the advantage of their changes to efficient use the system, and then take advantage, and then they can get more and more out of from system if they will use this virtual memory very efficiently. So here is the example. For example, that SQL mobile.dll is really used by device.exe, and if there is a DLL you have XYZ that is loaded by this particular and like my device.exe or my test tab, and then you can also define that DLL is exclusive. In this case, whoever will load this DLL which process, then if we can say, then the system will know that that's the DLL is exclusively loaded by that process. So you can define the DLL name loaded by the process, or DLL name only, so that whoever loads this DLL can be maintained. So here is the catch, and the catch is that the DLLs which are in module sections and loaded in slot 0 can take the advantage of this design, and the DLL should not be a resource DLL. As you know that the resource DLL, they use a different slot for their content. That's why the DLL must not be a resource DLL, and the DLLs in the module section loaded into slot 0. And for all other DLLs, the init vmmap will really directly ignore the request to use this efficient virtual memory management. So what really OEM needs to do for this one It's just when they use a module section, they can use the DLL which are in module section, they can just add a L flag. So it will force the DLL to be stay in slot 0, and then OEM or driver developer, they can take advantage of this thing. So that's the catch, and I think that should be enough to really understand these new changes. So I think that was it. So you learned about the changes we made in Windows Mobile 6.5, which OEM, ISV, driver developer take advantages, and not only this, they can also take this advantage of efficient virtual memory usage, the virtual memory gap which is created by the exclusively loaded TLL. So I think that was it, and I hope that you learned quite a few things by going through with this presentation. Thank you very much.